Welcome back, A-Peeps. Now we are jumping into the second part of Unit 1, which is going to focus on how we do scientific study in psychology. So we're going to talk mostly about the research methods that psychologists use to study the mind and behavior. So our essential question for this set of notes that I want you to think of is, how do psychologists use the scientific method to investigate questions about human thought and human and animal behavior? This is going to cover mostly Module 4 from your textbook. So let's start with a quote from scientist Richard Feynman. And this quote says, "The first principle is that you must not fool yourself, and you are the easiest person to fool." So this is talking about the fact that we as humans, we are actually easier than even the smartest of us think to fool. So we have to be aware of the ways that we can be fooled and our minds can be tricked into seeing or thinking different things so that we can study science in a way that is accurate and objective. So the first step is really knowing our limitations and how to try to address those as we approach this scientifically. So let's talk about why we need psychology as a science. So first off, why can't we just rely on our intuition or our common sense, right? We all have common sense and intuition. We know that scientists don't do that, right? We can't just go with our feelings, because sometimes our feelings are not quite right? Have you ever had a time where you thought that, your gut was telling you to do one thing and you go do it and then you're like, that was a bad choice? There's a movie quote that I can't quote directly because it has a bad word in it, but there's a movie called High Fidelity.
I've been thinking with my gut since I was 14 years old. And frankly speaking, I've come to the conclusion that my guts have a brain.
And I think that's a great quote because it's true. Like our guts are not always reliable. And then on the right-hand side here, you see the problem is I can't tell the difference between a deeply wise, intuitive nudge from the universe and one of my own boneheaded ideas. So we can't just rely on our intuition. And don't get me wrong, common sense isn't always wrong, but it's usually better at telling us what's already happened than what's going to happen. And this is an AP test tip from your textbook, and it suggests that you pay very close attention when psychological research counters what we know by our common sense. So I'll give you an example. Most people would say, well, yeah, it's common sense that having vitamin C helps you fight off the common cold, that drinking orange juice can help you fight off a cold. Well, actually, research shows that that's not true. And so we have to be careful because there are some things that have become widely accepted in common sense that really we've proven scientifically to be incorrect. So when we talk about psychological research and we get into research methods, I've heard it described by another AP Psych teacher as being like the game Whack-A-Mole. If you've never played Whack-A-Mole, it's what you see in the picture here. It's this great arcade game where these little moles are in their hole and they pop up and you have to hit them and you get points. And the longer you play, the more, as soon as you hit one, another one pops up and you got to get that one, and it's chaos. It's a fun game, but there's no perfect solution. The second that you address one mole, another mole pops up. And this applies to research methods in psychology because the second we address one thing that could throw off our data or our research findings, another problem will pop up. And I want to pause and talk about science as a field. There is what a lot of people call hard science and soft science. I hate that distinction because people tend to say, okay, the hard sciences are physics, biology, chemistry, etc. And they call psychology and sociology soft sciences. And the reason that that distinction developed is because hard sciences are science research that you can quantify. You can put it into numbers easily. I can measure the temperature of a chemical. In psychology, I can't calculate emotions. I can't put that into numbers as easily. So it's not as quantifiable, and that's why the social sciences get a bad rap. But the irony is that social science is a lot harder to study. for this reason, because of these moles. It's way more complicated. As soon as you get living organisms into the picture and you're studying what's going on in their own heads, it's so much harder to study that objectively. And there's no perfect solution. So keep that in mind. That's one of the challenges of psychology. And it's not something to be stressed about, but it is something that we have to think about a little bit more than you might have to do in another science. So if I'm conducting my own research, my goal as a scientist, as a psychologist, is to minimize the number of moles in my experiment or in my research. So if I'm considering someone else's research, so if I'm reading about another study that was done, then my goal is to find as many moles as I can and figure out, did they do a good job of reducing that? Now, a great question that I get every year is there ever a perfect world where you can get rid of all the moles? And to go back to our last slide, no, there's no perfect solution, right? Unfortunately, we don't live in a perfect world where there are no moles. Okay, there are no issues. There's always going to be some factor that could be interfering with our research. So our goal is to just try to get that number as low as possible of how many things could be messing with our data. So let's talk then about some of the quote-unquote moles that can make our research complicated as psychologists. And we're going to go into all of these. The first one is called hindsight bias. Hindsight bias is our tendency to believe after we've learned an outcome in a situation that we would have foreseen it. So I like to remember this as the I knew it all along phenomenon. That's another way to talk about hindsight bias. And of course, I'm a T Swift fan. I always think of the song, I Knew You Were Trouble When You Walked In. Well, she says that, but she's saying that after she saw how shady this boy was, right? How sus he was. So it's easy after that fact, and there's another quote that says hindsight is 20/20, which means when you look back on what happened, you can see it clearly. But that doesn't mean that when it was happening, you knew that was what was going to happen. But we as humans, we tend to think that after the fact, we're like, oh, I knew that was going to happen all along. They're the people that watch sports, and at the end of a sports game, they go, oh, I knew they had in the bag. I knew they were going to win. I think of my husband's a big Baylor football fan. A few years ago, there was a game where the kicker, it was all on the kicker. He had to make this kick, and if he made it, they would win, and if he didn't, they would lose. Lots of pressure, and he made it. He made this really difficult kick from really far away. And, I know there were people in the stands going, I knew he would make it. I knew it. I knew we were going to win. No, you didn't. You didn't know. Even if you were hoping, even if you thought, you didn't know until after the fact. So this is a tendency that we as people have. So a question I get in my world history classes every year is, oh my gosh, how could anyone have let a crazy person like Adolf Hitler become their leader? I would have seen it coming. I never would have let him get into power. The problem is that, it's easy to say that now on this side of history because we know what he did. But before that, when he was this little baby, he seemed harmless to everybody, right? Probably. So hindsight bias is we can look back and now we see, okay, it's easy to see that he was trouble. But when you're going through something, it's not always clear. So we have to be aware of that bias that we have so that we don't, it doesn't skew the way that we're looking at our research. And there are different categories within hindsight bias. You don't necessarily need to memorize these, but there are different ways that this can manifest itself. For example, you have the I told you it would happen, or you have the perspective of, well, it just had to happen. It was bound to happen. Or you have the, oh, I had a feeling it was going to happen. Now, here's a Turner tip, copyright 2020. Here's a Turner tip for the AP exam. There are going to be a lot of terms throughout the year that are easily confused with each other. So this is what I would call confusing pairs. One of the biggest confusing pairs of the year is the term hindsight bias, which we just learned, and another term we'll talk about later called confirmation bias. The difference is hindsight bias is the belief that you could have predicted something that happened in the past. Okay, we just talked about it. Hopefully that makes sense. Confirmation bias is going to come up again later, but basically it's when we only look for the information that supports what we already believe. So for example, think about a common debate about anti-vaxxers, right? An anti-vaxxer, if someone is an anti-vaxxer, then when they go to research vaccinations and the risks of vaccination, they're only looking for articles that support anti-vaccination, that are from their side of the argument. They're not going to read the articles from people who support vaccination. And that's confirmation bias. They are biased towards the information that confirms what they already believe. And unfortunately, this is pretty much Facebook nowadays. This is how a lot of people handle the internet and debates, which is why it's not very useful to debate things on social media anymore, because people aren't really looking for an intellectual debate. They just want to look for someone to say they're right. So we have to, as scientists, be conscious of that bias as well, because we don't want to only look at evidence or data that supports what we thought was going to happen in our research. We have to try to be as objective and removed emotionally from that as possible. We have to think of it as just what is the data showing me, not what do I want it to show me. Okay, now I want you to try something. In your notes or on a scrap sheet of paper, I want you to write a list, and what you're going to do, I'm going to put up a prompt, and you're going to tell me a number. Give me a range of numbers, so like 0 to 100 or 10 to 5 million of what you think the real number, the real fact or statistic will fall into. So give me a range you think it will fit into, so much so that you're 98% sure that the answer will fall within the two numbers you gave me. So for example, on the first one, tell me the area of the US in square miles. Now don't cheat. I know you have a device in your hand right now that you're using. Try not to Google. Okay, so you're going to give me two numbers for number one. Between these two numbers is where I think the US area in square miles will land. Then you'll put the population of Australia in 2007. How many deaths in the Spanish-American War? How many American deaths? How many female psychiatrists were in the US in 2005? And how many operating nuclear plants were there worldwide in 2007? So I'll leave this slide up here. Don't move forward. Pause the video. Write your answers down, what you think, and then we'll come back and I'll tell you about it. All right, welcome back. Let's check your answers. Okay, so number one, the area of the US is 3.6 million square miles. Number two, the Australian population was 20.4 million in 2007. The US or American battle deaths in the Spanish-American War was 385. The number of female psychiatrists in the US in 2007 was 13,079. And last but not least, the number of nuclear plants in 2007 was 435. So how did you do? Check your answers really fast and see how many you got correct. And remember, you're correct as long as the number on the right-hand side falls between the margin of what you wrote down on your paper. Now, what you might notice is that you could easily hack this game, right? This activity, because all you had to do was put 0 to infinity, right? You could put 0 to infinity and get all of them right, or 0 to 5 billion and you would have gotten all of them right. But most of you probably didn't do that. You probably actually tried to get as close a margin as you could to get that number in there. And so the reason that we tend to do that is something called overconfidence. And overconfidence is just our tendency to be more confident about our abilities and our own predictions than we probably should be. So, and this, we're all susceptible to this. We tend to be overly confident about our abilities to do something or to predict what will happen in a situation. Another thing that can be a mole in our research as psychologists is our tendency to want to perceive order in random events. So as humans, we want to find order because randomness can be disconcerting for us, right? We like routine. We like to know, that this leads to that. It's a little scary for us to not have any kind of order in the world. So our brains automatically want to do that. They want to make sense of the world around us, and they want to have rules and regulations for what's going on. So we tend to see patterns that may not necessarily be there. So for example, if any of you ever watched the show Glee, there's an episode called The Grilled Cheeses.
When I pulled the sandwich out, I saw the face of God. Literally, I had made a grilled cheeses.
And it's based on just this idea that people see things that may not necessarily be there. Okay, so let's test this, all right? Let's put this into practice. Here's what I want you to do. Grab a piece of paper. It can be a piece of notebook paper. It can be a Post-it, scrap paper, something to write on. So I've got my legal paper here. And if it's a piece of notebook paper, you're going to fold it in half hot dog style. So you have two sides. You have a fold down the middle. On one side, you're going to number 1 to 10 and then number 1 to 10 here. At the top on this side, this is going to be your predictions. So you can label that predictions. And then over here, you can just say like real results. And here's what I want you to do. Find a coin, if you have one, and get a penny is best. And you're going to record whether you flip it 10 times or 20 times. Do you get heads or tails? So before you start, go ahead and on the left side where you wrote down prediction, you're going to, for all 20, I want you to predict, are you going to get heads or tails? So just write the pattern you think is most likely to happen. So you might put heads, heads, tails, 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 okay, or heads, tails, heads, heads, tails, heads, tails, tails. Okay, write a prediction of what you think your tosses will be, 20 tosses in a row. Then, when you're done, you're actually going to flip a coin 20 times and record whether you got heads or tails. And what I want you to do is then you'll look and see how those two lists compare. So pause the video and try this out, all right? First write your predictions, then actually do 20 coin tosses and see what you get. And we're back. Okay, so how did it compare? Which list looked more random to you? Was it your predictions or was it the actual tosses? My guess is that your predictions were actually more random than the data that you collected as you flipped your coin 20 times. And why is that? Because we tend to think that things are more random than they are. So, or that real randomness is less, consistent. So what I mean is, usually when we do this in class, in person, I actually have everybody write their predictions and they write the other list of their results and they don't label them. And then I come around and I have to try to guess which one is the real results and which is the prediction. And then I tally how many I get correct. Guess what? It's pretty easy to guess which was the actual result. Because when you write a prediction, you tend to think it's going to be more random than it is. So you probably on your prediction side have a lot more evenly distributed results. So you probably have something like heads, tails, heads, heads, tails, tails, heads, 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 tails, tails. And then on the actual side, you might have 5 or 6 heads in a row or 5 or 6 tails in a row, which you would never guess would happen randomly, but it actually happens more often than not. So that just shows us that we don't always realize what randomness actually looks like. So when it comes to approaching psychology as a science, we have to have what we call a scientific attitude. And that means we want to be curious and we want to be skeptical, but we also want to be humble. So how do we balance skepticism with becoming cynical or being open-minded but not gullible? That's the challenge of being thinking scientifically and thinking critically. So that's something that we're going to hopefully learn and get better at throughout the year in this class. So when it comes to the scientific attitude, you might hear me say this quote: The rat is always right. In a lab, you always see scientists doing experiments on rats. And what this really means is that the data is always right. Look at the data. What does the data say? Not what do I want it to say, not what do I think it should say, but what do the numbers actually say without me trying to, manipulate them to say what I want. Having curiosity and skepticism is looking at research, looking at data, and asking ourselves, what does it mean? How do we know something? How do we know anything in our research? How can we make a conclusion? How can we say that that is the case? And humility is just being aware of our own susceptibility to making errors and being biased, and also being open-minded about other people's perspectives or about surprises that come along the way. So when you start a psychological experiment, you might have an idea of where it might end up going. You have a hypothesis. You're going to hypothesize what you think will happen, but it's not about proving your hypothesis right. It's about addressing a question, a scientific question, and then seeing how the data either supports or disproves your hypothesis. So to be a successful scientist, that doesn't mean I proved my hypothesis right. It means I learned something about the hypothesis. It's not a failure to prove your own hypothesis wrong. You're still learning something, and now you can move forward. So that's what we mean by balancing these different elements of the scientific attitude. And then when it comes to critical thinking, I like to say it's smart thinking. So thinking that's not blindly accepting arguments and conclusions. It involves all of the things you see in this diagram here. So think analytically, don't just accept things at face value. Question everything, right? Question, where is this information coming from? There are so many articles on the internet about psychology, and they'll say, psychologists just proved that blah, blah, blah. And if you really read the article and you look at how they collected the data, it's questionable. So you don't just read the headline and accept that as scientific fact. You have to think critically about it. So my goal is to challenge you to become a critical thinker. And a critical thinker is always asking to show the evidence. So they look at the evidence, they can recognize different perspectives, and they are willing to expose themselves to news sources that challenge what they have previously believed, what they think. So be open, be willing to be challenged and to have your beliefs challenged by what's going on, and look objectively as you can at what the data says. So in your textbook, you can read in more detail how psychologists use the scientific method. I'm not going to spend a lot of time on it in this video because this is something you should be familiar with from your other science courses. So just to give you a quick recap, the scientific method is just the systematic approach we take to scientific study. It is a uniform system, a step-by-step process that all scientists use when they conduct research. Why do we all use the same method? Because if you use the same method as somebody else, you can compare your results. But if you change one step of the process of how they did their research, you cannot compare your results. It's apples and oranges. Let me give you an example. As you know, COVID interrupted the school year last year. I was really upset for many reasons, but one of the things that really made it stink for me is that it was my second year teaching AP Psychology, and I was really looking forward to comparing my student scores from my first year to last year's scores. And I realized that I wouldn't be able to do that in a way that was scientifically valid because COVID was a huge mole, right? It threw everything off. So my students last year had a much different experience and a totally different exam structure than the students my first year. So it's great that my, students last year, they did so much better numerically on their scores than the first year. We increased our passing rate from 26% to over 50% of MAC students passed the AP Psych exam last year. That's awesome, and I'm super happy, and I celebrate that. But I also realize I can't compare what I did last year with those students and how we did things with the first year because there were so many factors that could have affected that. So unfortunately, we didn't use the same system, so they're two different things. And so, if I do an experiment one way and then I repeat that experiment, but I change one element of it, then it's now a whole new experiment. Even though they look almost the same, it is now considered totally different because that one factor could be changing my results. So you'll hear me talk about this throughout the year as we start thinking critically about different psychological experiments and case studies. Okay, and that is all I have for you for this set of notes. Join me again later this week to talk about specific research methods that psychologists use in our field to study the mind and behavior. And Zoom this Thursday, we are going to talk specifically about the FRQ writing portion of our exam, and we will talk a little bit about the research methods and do a little bit of practice with that. So I will see you then. Bye, guys.